climate education because people matter. So to begin with, what I want to do is to tell you two stories that I have come across in my own exploration. The first story I call The Scientist, the Elder, and the Sea Ice. And it is set in a place very far away from our part of the world, in the Arctic Circle. So you can see that this picture on the right is a picture of the North Pole. And I happened to be in 2014 standing right about here at the North Shore of Alaska. And I heard this story from a geophysicist who had been working in Alaska for 30 years. And this is what he said. He said that 30 years ago, when he first went to Alaska to study sea ice, and sea ice, as you can see from this picture, is the frozen surface of the Arctic Ocean, then he had a very interesting experience. He and fellow scientists walked from the shore onto the sea ice, and the sea ice in winter can often be 4 or 5 meters thick, so you can walk on it. So their purpose was to go to the edge, to the liquid water boundary, and set up camp and study sea ice. So they walked to the edge, which was about 2 or 3 miles from the shore. And they were about to set up camp. They were unpacking their instruments. It was a beautiful day. The sky was blue. There was no report from the meteorological office that there would be any currents or bad weather. And as they were unpacking, the native elder, who was their guide, suddenly said, "We have to get off the ice right now, right now." Now, the place that this takes place is close to the town of Utqiagvik, which is the northernmost place in Alaska. And if you go any further north, you basically are in the Arctic Ocean. So, and the people who live there, the town of Utqiagvik has about 4,000 people, most of whom are a tribe called the Inupiat, and they have been living there for thousands of years. So the native elder, when he said, "Get off the ice now, we got to go back to the shore," at first the scientists didn't believe him. They had no reason to. But somehow the urgency in his tone communicated it to them, and they packed up and rather reluctantly followed him back towards shore. And as they did so, there was a deafening crack, and the piece of ice on which they had been camped, or they were intending to camp, broke off from the rest of the shore ice and floated off into the Arctic Ocean. Now, the thing is that especially in those days when there was no rescue and search mission, that would have been a death trap for that group of scientists. So the native elder had actually saved their lives. And the scientist told me, the geophysicist who told me this story, said the following. He said that I thought I knew the ways to understand sea ice, but clearly there were other ways to understand sea ice that I didn't know about. Okay, so that's my first story. My second story brings us much closer to home, to Jharkhand, which is one of the most climate vulnerable places in the world. However, this particular story does not even mention climate change. This is a group of women in an impoverished village in Jharkhand who regrew their local forest. In Jharkhand, what is happening is essentially large-scale desertification due to deforestation, due to mining and quarrying. Now, this is not an unusual story at all in India, but I happened to speak to Parvati Devi a few years ago on the phone. She had to travel 5 kilometers to find someone who had a phone to talk to me. And she told me how that entire region used to have thick contiguous forests, and many of them had been cut down, and all that was left was 200 hectares of degraded forest. So 20 years ago, when they found that the water table was dropping, and the agricultural productivity was threatened, these women got together and started patrolling the forest, including the sometimes dangerous task of confronting would-be loggers. And not only did they patrol the forest and make sure that they themselves did not overexploit it, but they also dug ponds for the animals so that the animals could have water. And they made mud and stone check dams with their bare hands to prevent the streams from going out of the forest into the desertified landscape. So more than 20 years later, as attested by a friend who visited them, the tree trunks have thickened, many of the animals have returned, except species like the tiger. The water table has gone up, agricultural productivity is better. She told me that the malarial menace had also decreased, and the local microclimate has become cooler. So that's my second story. And we're going to come back to these stories and what they mean for climate education. But before that, what I want to do is to make some preliminary comments about climate change so that we are all on the same page. So what is climate change? Well, first we have to understand the difference between climate and weather. And I know many people already know this, so forgive me if I'm being redundant here. But we know that weather is a short-term local atmospheric condition. We talk about the weather in Delhi today or tomorrow or during this week. We talk about the climate of the Indo-Gangetic Plain or the Central Himalayas and so on. So climate is always longer term and larger regions. And climate change is the change in these atmospheric conditions over large regions and long time scales due to both natural and human causes. However, current climate change is, we know, primarily due to the activities of modern industrial civilization. Earth's climate has changed many, many times in its 5 billion year history, and most of the time due to natural causes. This particular climate change era is because of modern industrial civilization. And that has caused global heating, as we know. So, moving on. This is not a talk about the basis for climate change or the science of climate change and its details and its impact. So I'm going to summarize a lot. And so I'm going to summarize 5 key major takeaways about climate change because I won't have time to talk about them in detail. So firstly, it's real. Secondly, it's caused, as I said, primarily by activities of modern industrial civilization. And it is serious. It is a major existential threat to humankind and the biosphere with impacts on all aspects of society. It's happening now. It's not a far future problem, and it's getting worse. And it worsens all other social environmental problems. So we are headed towards an Earth that humans have never known. This graph shows us the carbon dioxide levels in the atmosphere from approximately 1 million years ago to 2008. And you can see a couple of interesting things about this graph. Firstly, human beings show up as a species between 300 and 200,000 years ago. So all the changes that have preceded human beings, and also right up to, environmental historians have a better idea of this, to the rise of agriculture and then more recently the Industrial Revolution, the climatic changes were entirely due to natural causes. You can also see that carbon dioxide here is measured in parts per million, which is extremely small. In fact, carbon dioxide gas is only 0.04% of the gases in the atmosphere. And yet, if you look at these up and down swings, which are only a change of 100 parts per million, these constitute the difference between a glacial era, where the northern hemisphere is covered most is what we are in now and have been since 12,000 years ago. So you can see that a little carbon dioxide goes a very long way. And you can also see, and especially if we could expand this scale, we would see that this spike in the level of carbon dioxide begins in the late 1700s with the Industrial Revolution, where there is, for the first time, a large-scale burning of fossil fuels, coal, oil, and natural gas, starting with coal. And the current 2022 carbon dioxide concentration is 415 parts per million. So we are headed towards an Earth that human beings in all our evolutionary history have not known. Here's another picture that demonstrates that. This is a diagram from a very important paper that came out in 2018. So if you look at the up and down, the glacial interglacial cycles, which was where the Earth was, and you think of this as a landscape of the states of the Earth, of the states of the planet, then we were essentially in this blue zone, kind of going back and forth between glacial and interglacial cycles until the mass burning of fossil fuels kind of kicked us out of that. And we are headed towards a trajectory, potentially towards an unknown hothouse Earth, which may, for all we know, be literally hell on Earth. There's a chance that we could perhaps change the trajectory to some extent, and that's partly why this problem is so very urgent. So having established, I hope, the crucial importance of the climate problem, I want to pinpoint the impacts on India very quickly, there was an assessment of climate change over the Indian region, the first Indian assessment that was issued last year by the Ministry of Earth Sciences. And you can see that these are very grim notions here: heat waves, changing rainfall patterns, food and water insecurity, which is bad news for agriculture, refugee migrations, including within the country if certain regions become uninhabitable, extreme weather, ecosystem changes, species extinctions, changes in relationships between humans and animals, from various kinds of coexistence to more confrontation. Glacier melt, sea level rise, energy security, and then very recently there's a report from Nature, from the journal Nature, that we are entering an era of global pandemics. So COVID-19 is the first warning of what might be a series of pandemics. So a lot of terrible news. All right, so let's see what we need to do about it. So in order to deal with a problem of this magnitude, of course, we have to adapt to current and future changes, and we have to prevent climate change from worsening, and we have to do these urgently. What I'm going to focus on is the role of education, or the potential role of education in confronting and dealing with the climate crisis. So let me quote briefly from a report that just came out this month, which was about some alarming findings about climate education. Excuse me. This was based on the nationally determined contributions that different countries in the UN climate negotiations, what they have, what their contributions are to climate adaptation and mitigation. Now it turns out that countries are not paying enough attention to climate change education. And if education is to be one of the tools for us to adapt, to create knowledge, to create technical expertise for the massive changes that are needed, but also to prepare society for large-scale societal changes, then that's a problem. And countries are not considering strengthening education systems either. And the other thing that's happening is that countries continue to ignore the contribution that an investment in girls' education, which research has shown has a lot of ripple effects in other sectors as well. That is something that continues to be ignored. Additionally, the countries that are most responsible for the climate crisis, and that's North America and Western Europe, they do not even mention climate change education as part of a climate strategy. So it's not just that climate education is ignored in terms of infrastructure changes in education and putting monetary investment in education, but it's also the kind of climate education as it exists today that is not working. And another important report from 2020 points to that globally the education system has failed us in terms of getting a grip on climate change, and potentially it should equip us to help deal with both adaptation and mitigation. Why has it failed? So of the many reasons identified by experts, I pinpoint 3 of them. And what I want to focus on is actually the last one, but I want to mention the importance of environmental literacy in general, which is at the bottom of the priority list in most education systems. But the last point, the lack of radical visions for climate education. If climate is a problem that has defied our frameworks, all of our frameworks for making sense of the world, and indeed we can say that it has, because the climate problem is getting worse every year. Carbon dioxide emissions are increasing every year. So clearly we have failed to grasp and engage with the problem usefully. And part of that is that it confounds our existing frameworks for making sense of the world. So what I'm trying to do is to come up with radical visions for climate education. And I am, like many people, only an explorer in unknown territory. But I want to share some of my explorations with you in the context of climate education. So my story is this, that I'm a particle physicist by training. And so about 15 years ago, when I started getting worried about climate change, I taught myself the basics basics of climate science, enough to teach it in my general physics college courses, because I wanted to equip my students with knowledge for the future so that they could be ready for the changes and also hopefully be change makers towards a positive future. That was very naive, and my early experiences were failures. Now, I always tell my students it's very important to learn from failure. So I tried to live up to that. And I thought, what is it that I'm doing wrong? I'm teaching climate science in a physics classroom, and my students are getting depressed. They're turning away. They don't want to know more about it. And and at the cognitive level also, they don't have a holistic understanding of climate change. So since then, for the last 12 years or so, I have looked at the climate phenomenon itself as a teacher, trying to go to it to the extent possible without any pre-existing frameworks. Now, that's totally impossible at one level, but I have tried my best to be aware of pre-existing paradigms and frameworks and to come to it almost like a child. Okay. So that has led me towards a transdisciplinary, justice-centered, always developing pedagogy of climate change, in which I'm always learning from my students, from climate scientists, and also from communities. So if we look at the climate itself as teacher, and if we look at the two stories I shared with you, which are two of about 15 stories that I've collected, then some things become obvious. One is that climate breakdown spans vast spatial and temporal scales. We see that global heating manifests in the Arctic differently than it manifests in Jharkhand. In fact, my Jharkhand story does not even mention climate change. It mentions deforestation due to quarrying and mining. But it's true that Jharkhand is also very climate vulnerable. So when we look at the context of these two stories, then we learn about, for instance, the history of land rights struggles of the native peoples in Alaska, the history of colonialism in India, and the history of caste and class hierarchies. All of these intersect when we look at the environmental situation of those two stories. So when we look at the global notions of what's happening to the climate and what's happening to the environment, often the global perspective becomes the privileged perspective. But it's at the local scale that change happens, that people suffer impacts, that people can figure out how to adapt and mitigate. So the local histories and the local context matter as much as the global, and it's important to find connections between the two. The other thing, of course, as I hope is obvious from those stories, is that the climate crisis is inherently transdisciplinary. It cannot be seen in isolation from other issues, other subjects, other disciplines than the sciences. And also, as I hope to show, it is inextricably entangled with other large social environmental problems. The climate system is a complex system. I'm going to talk about that a little bit later. And central to the climate problem is the issue of justice, because neither the tribes in Alaska nor the impoverished villagers in my story from Jharkhand actually created the problem of climate change, and yet they are the ones who suffer the worst of the impacts. So if we look at and if we compare these key features of the climate crisis with how we are taught to think in modern industrial civilization, in modern education systems, and this is a huge oversimplification, so please forgive me for that. But if we contrast the two, and we see how a crisis that is inherently entangles spatial and temporal scales, whereas we are encouraged to think short-term and local, and our empathic reach is limited to maybe our family and friends or people like us in terms of caste and religion and class. Yet we have to look at everything holistically because the climate crisis warrants that. The important point with regard to education is that to deal with a transdisciplinary crisis in an education system that separates the disciplines, where sociologists don't talk to physicists or economists to poets, that is a serious problem. Nor are we taught to recognize and work with complex systems, whereas most of the systems in the world consist of, in fact, are complex systems, including global climate. And for a problem in which justice is a central feature, we live in such unequal power hierarchies that we are often blind to inequality. So is it a surprise then that education, as we know it today, fails to engage us critically with the climate crisis? So my explorations have led me to ask this question: what is an effective pedagogy of climate change? And through the teachings of climate, this is what I have come to understand, that it must be a transdisciplinary pedagogy. It must emphasize relationships and teach about complexity and complex systems, emphasizing connections to other problems, and to look at the common roots of all of these other problems, which I hope to talk about if I have time. It must center justice, equity, ethics. It must be able to critically evaluate purported solutions, because we hear climate solutions now from every corner. And then therefore to go towards what is real action, what is meaningful action, and how do we empower our students and communities, and most importantly, how do we enlighten policymakers for meaningful action. So my approach to climate pedagogy, from my perspective, is really that there are 4 dimensions to it, and that climate justice is central. And those of you who might want to know details can find them in a chapter in a book that has just come out from UNESCO last year. So what I'm going to go quickly into is to firstly quickly mention that there are many ways to think about meaningful climate education. So what about climate education across the curriculum? So Italy, for example, is experimenting with teaching climate change in every class, whether it's maths or geography or physics. Then there are other experiments where you have a special required class on climate and sustainability and environment, and everybody has to take it. Then thirdly, and this is my context, where we don't have the earlier 2 options. So what I do is to try to teach climate change effectively from using the core ideas that I've just described within a traditional class. In my case, a general physics class, but it could be a class on literature or sociology or anything else. So what do we all need to know about climate change, no matter which discipline we're in? Now, I don't have a complete or a set in stone answer to this question, but from my explorations at this point, this is what I have learned. So what I do is I describe 3 large concepts, which I call meta concepts, which embrace essential features of climate science, but also are transdisciplinary, because they kind of reach across the disciplinary barriers. And these 3 concepts are the idea of balance or imbalance, the idea of planetary boundaries, and the notion of complexity or complex interconnections, with justice as the connective tissue of these 3 concepts. So I'm going to describe these briefly. I'm going to try to refer to the 2 stories I told you to the extent possible, while keeping an eye on the time. So let me go ahead. All right, so let me talk about balance and imbalance. What do we mean by that? If you want to be more technical, these would be steady state versus change of different kinds. So let me begin with the Arctic, since I've studied that to some extent and I'm familiar with it, and then we are going to relate it to more familiar things. So if we look at, for instance, the amount of sea ice in the Arctic, the frozen surface of the Arctic Ocean, it is going down in its mass, in its total extent, and therefore its mass. So this is actually when, for a very long time, since the end of the last glacial era, the total mass of the Arctic until about, well, the data collection starts in the 1980s, so we don't know what happened exactly before that, but it was roughly constant. Why? That was because the processes that add sea ice to the ice cap and the processes that remove sea ice from the ice cap were working at the same speed. And that was a state of dynamic balance or steady state. Now, what's happened now, as you can see from the size of the arrows, that the processes that remove sea ice from the Arctic are acting faster than the processes that add sea ice. And this is sea ice mass imbalance. Okay, so I hope that this is clear. So the mass of ice in the sea ice is falling and the extent is falling, and this is what this graph shows. Arctic temperature is rising 3 times as fast as the global average. So this is actually related. So this regional effect is related to planetary scale imbalances, the carbon cycle being the chief instigator. So similar to the sea ice mass balance or imbalance, there's a carbon cycle balance or imbalance. So the carbon dioxide concentration in the atmosphere, it depends on the processes that add CO2 to the atmosphere, like when we breathe out, we generate carbon dioxide, so we are a carbon source. Processes that take carbon dioxide out of the atmosphere are called carbon sinks. Among the most important is photosynthesis, green plants on the oceans and on land. So when these two processes, carbon sources, are acting as fast as the carbon sink, then the amount of carbon dioxide in the atmosphere stays constant. But as you can see from the size of the arrows, by digging up fossil fuels from the ground and burning them and adding new carbon sources, and at the same time undermining carbon sinks by, for example, destroying tropical forests, but not just tropical forests, also grasslands and other ecosystems. We are undermining carbon sinks. So there is an imbalance in the carbon cycle, and which is why the graph of carbon dioxide that I showed you earlier, which goes up and down through the glacial interglacial cycle, suddenly shoots up because carbon dioxide is building up in the atmosphere due to this imbalance. And that has an impact immediately on the Earth's energy, because the energy in the Earth system comes primarily from the sun. And if the sun is adding energy at a certain rate to the Earth, and the Earth is, of course, emitting it out in the form of gentle heat waves into space, if those two processes are working at the same rate, the amount of energy in the Earth system is fixed, and therefore the temperature is fixed. But since what carbon dioxide does is to trap heat, in a manner of speaking, in the Earth system, then the Earth is not able to get rid of the energy from the sun as fast as the energy comes in. So that is the cause of global heating. And that is directly related to Arctic temperatures rising and the retreat of the sea ice. So this is the concept of balance and imbalance. The second large concept or meta concept is the one of planetary boundaries. Now, I want to go back to this slide for a moment, and I want to point out something, that if you have a system that can be in these two states, balance or imbalance, stasis or change, okay, then that means that there must be a boundary, either narrow, either abrupt or broad, gradual or sudden, between those two states. So, for example, if I'm standing on the toes of one foot and trying to balance, I may have a little bit of resilience. Like if I tip over a little bit, I can kind of, tip back and go back to, a relative balance. But maybe if you pull on my arm just a little hard, I'll start to fall over, which is a state of imbalance. And ultimately, I'll reach a new state of balance lying on the floor, which may or may not be a good thing. So the point here is that when you have a system that can go from balance to imbalance, then it must cross thresholds in order to do that. And the planetary boundaries concept, which comes from research at Stockholm University, identifies 9 such thresholds. So planetary boundaries are basically thresholds set by natural cycles to which we are indebted for creating what they call a safe operating space for humankind. In other words, the biggest lesson here is that we can't do whatever we want. We have to stay within certain limits defined by natural cycles for creating a habitable planet that is good for humans and the biosphere. Violating even one of these boundaries can threaten human civilization and the biosphere. And scientists conclude that we have so far violated 5 such boundaries. The important thing about this is to note that these boundaries are not separate. You see, climate change is among them. Biosphere integrity, we are in the middle of a massive species extinction. These are related. All of these planetary boundaries, these natural cycles, are related to each other. So, for example, climate change is one of the primary drivers of species extinction. So the planetary boundaries framework is really important because it clarifies that we are indebted as human civilization, as human beings, to natural cycles and processes, which classical economists were not aware of. So our entire 20th century economic theories are based on ignorance of this clear and important reality. They also show that the social is always entangled with the scientific. I'm not going to be able to go into details. There are some important critiques of the planetary boundaries framework. It's a work in progress. Nevertheless, it's very useful for pedagogy because, among other things, it makes it clear that climate change is only one of multiple social environmental problems, including species extinction, nitrogen cycle imbalance, land use changes, and plastic pollution, because they're all interrelated. So so there's a term called climate reductionism, or carbon reductionism, where our focus is only on lowering carbon emissions. Of course, we have to do that, and we have to do that urgently. But we cannot do that by ignoring all the other problems that threaten us. So we are confronted with a complex of problems and not just climate change. And as we'll see, this behooves us to look at the roots of these problems. Do they have common roots? If they're interconnected, how did they come to be? Before I get into that, I want to point out a little thing about sea ice loss. So because we've been talking about the Arctic. So loss of sea ice and the thawing of the land itself, where permafrost is the frozen soil and water which constitutes the tundra. That has major consequences that are both regional and global. So in other words, I've talked about planetary boundaries, but there are also local regional boundaries. And I'm just going to mention a couple of things here. So, for instance, the sea ice loss and permafrost thaw are a direct threat to the survivability and the cultural well-being, as well as, things like subsistence hunting in the winter, which is a main source of food for the tribal peoples there. So it's a threat to people who live in that region. And in part, that threat is because of the fact that sea ice is the basis of the coastal Arctic ecosystem, so that there's a cascading series of changes all the way to polar bears and humans due to the melting of the sea ice. Now, the thing is that what happens in the Arctic doesn't stay in the Arctic for a number of reasons. I'll just mention one of them. The sea ice loss and permafrost thaw are both impacted by global climate change and in turn have influence on the global climate. And the one thing I'm going to mention is that the tundra is a huge carbon sink. There's a lot of carbon locked up in the tundra. So, we often think about forests as important carbon sinks, and they are really important, but they're only among the top 5 carbon sinks. There's grasslands, there's coastal mangroves, there's seagrasses, there's the tundra. So we need to be aware that all ecosystems need attention. And the tundra is really important because as it warms, it's actually starting to give off carbon dioxide and methane. Methane is also a very powerful heat-trapping gas. So if the tundra crosses that boundary between being a carbon sink and being a carbon source, that has serious consequences for the global climate system. So let me go back to the question that I raised just a couple of minutes ago in the previous slide on what might be the common roots of the problem. And when you dig deep enough, then it becomes clear that our socio-economic system that is now globalized is based on exponentially increasing material resource extraction and use, and ultimately the exploitation of people and the rest of nature. This is a sketch that an artist friend of mine made to show economic inequality. The richest 10% of people produce 50% of the planet's individual consumption-based fossil fuel emissions, and the poorest half produce only 10%. So you can see how justice is so central to everything that we are talking about here. So one of the measures that reveals the problem, the root of the problem, is called the material footprint. So most of you would be familiar with the carbon footprint, right? How much carbon emissions result due to a technology or a nation or the globe or whatever. But the material footprint is a more comprehensive measure that has recently become important. And basically what it does is it captures the biomass and all the material in metric tons from extraction and mining all the way through manufacture and production to use and disposal of any technology, and can be aggregated over nations and the globe. And you can see from these graphs that which show cropland extent, global fossil fuel consumption, global freshwater use, metal production, plastics production. These are all familiar mathematical curves. These are exponentially rising curves. And this tells us something very important, that although we need to do things like changing from fossil fuel infrastructure to things like solar and wind, simply replacing one technology with another is not going to do it. Because if our material resource extraction is at the root of our multiple problems, not just climate change, then as long as demand continues to rise, we're going to see, even with electric vehicles and things like that, that we are going to ravage the planet. We are going to cross multiple planetary boundaries. And this makes us rethink, calls for us to rethink what real sustainability means. So that's my second meta concept. So I've talked about balance and imbalance. I've talked about crossing planetary boundaries. And the last one I'm going to talk about is complex interconnections, the idea of complexity and complex systems. So this diagram is from a very important paper, the one I mentioned earlier. And what this shows is a bunch of regional climatic phenomena, okay, or features. So you have Arctic sea ice, winter and summer. You have the Indian summer monsoon. You have, ocean circulation, all of those things. It's only recently that climate scientists are beginning to figure out and to quantify gradually the relationships between these two, because all of these are connected to each other. So there's a recent paper, for instance, which talks about how the vanishing of Arctic summer sea ice is going to change ocean circulation patterns, which might intensify the drying out of the Amazon rainforest. So you see that these regional phenomena are like dominoes, that if one of them changes drastically, if a regional boundary is crossed, because they're connected to each other through non-linear complex interconnections, and if they're going to change the other regional phenomena around them, and if the change is all in the same direction, then the entire system changes to a new state. So what are complex systems? I'm going to quickly talk about what they are. Like a simple system, a complex system consists of interacting parts. But the difference is that the interactions in complex systems are strong and non-trivial. And we can say simply that they're just as important as the parts. And I'm going to quote Aristotle here, the whole is greater than the sum of its parts. It's a good description of a complex system. They abound in our world, the human endocrine system, ecosystems, the global financial system, and of course the global climate. And they have certain important features. The study of complex systems as systems, instead of just looking at the individual parts, is relatively new. But we do know that they have features, which I'm not going to go into details right now, except to say this, that because the interrelations are important and often really strong, they can even change the nature and function of the parts themselves. Okay, so for instance, I just talked about the tundra being a carbon sink, but it can change into a carbon source. The same can happen with the oceans, and they can exacerbate through the interconnections, just as I showed on this previous picture. They can exacerbate an originally or initially small effect, such as global heating. So studying complex systems is really important, and it's tragic that in our education system we don't study them right from the start. So this actually relates to the two stories I told you, in that often we don't, when we're studying climate change, we don't look at interconnections between different and remote parts of the globe. Some of you might be wondering, if you're new to thinking about climate change, why am I talking so much about the Arctic, and why should I care about the Arctic? Well, as I said, what happens in the Arctic doesn't stay in the Arctic. The shiny parts of the globe, the great ice sheets, the polar ice caps, the glaciers on the mountains in the world, have a very important role to play in regulating the Earth's temperature, because they reflect without absorption, along with clouds, 30% of the sun's energy back into space. So as glaciers melt, as the sea ice shrinks, as the large ice sheets melt, more of the sun's energy is going to be retained in the planet, and through various complex causal connections, that is going to translate to more heat waves in places like Jharkhand. So what does complexity teach us? What does the climate teach us? Ultimately, we are connected across time and space. What happens in one place, it can potentially trigger changes in other places. So I'm not going to go into details here, but this picture summarizes everything I've talked about so far. So here you see the 5 traditional subsystems of the climate as identified by Earth scientists. And then some people say that we should introduce human activity or the human sphere, the anthroposphere, as a major driver of geological scale change. I prefer to use the term modern industrial civilization as being slightly more accurate than anthroposphere, because as you see from the two stories I told you, not all humans are equally responsible for or equally impacted by climate change. So, which is why I put marginalized human groups a little bit aside. So anyway, not to go into too much detail here because of time, but I want to reiterate the centrality of the justice issue. And to come back to, and in the last, I'm just checking the time here. I'm actually not going to talk more than about 3 or 4 minutes. So I'm going to skip large portions of what I was going to say. So to come back to this picture that I showed you earlier, what is an effective pedagogy of climate change? I hope you can see from the two stories and from talking about their context that these multiple dimensions are essential for an effective pedagogy of climate change. And there are two dimensions I haven't even talked about, the psychosocial dimension, which has to do with meaningful action, and the epistemological dimension, which has to do with how we construct our reality. How do societies think about what are the concepts through which we make sense of reality? And so skipping that to some extent, actually maybe I have time just to share one example. So I'm going to make a claim. This is an oversimplification, but it's a useful one, that the way we think in modern industrial civilization is based on what I call the Newtonian paradigm or framework, which is a mechanistic way of thinking about the world. That our ultimate model, whether it's the human body or the economy or nature or society or the education system, is a mechanistic one, that we think of it as a machine, like a clock. It has gears and springs. We understand the gears and springs, we've understood the clock. Therefore, it is reductionist and also atomistic. And it invites the illusion of control, that that a machine is something you can control. And it's also impersonal. It separates us from other aspects of us and other aspects of society and the ecosystem. So it's also, in that sense, distancing or impersonal. So without going into details to justify why I'm talking about this, and simply making the claim for a moment, which you should feel free to investigate on your own, that this is the way that we are taught to think. And a great example of this is an education system where we separate out the disciplines into these silos, into these watertight compartments that don't talk about each other or don't talk to each other. Then I want to give you an example of how, you can see from my description of complex systems and Earth's climate, that Earth's climate is actually not a simple system. It's not a Newtonian system. It's not a machine. It's something that's alive and organic. And yet we think about the climate problem in a mechanistic way. And that is a problem. That is a serious problem. So it's not only that the climate crisis demands that we look at at the different aspects, like the kind of technological changes that are needed, the kinds of sociological changes that are needed for adaptation and mitigation, all of that. But we need to rethink how we think. And I'm really sorry that I haven't had time to talk about it, but I'm just going to mention I'm going to show you one quick picture. This is a standard default view of the economy as something that encloses nature and society, and where individuals are considered the natural unit of society. So for an example of this is that even the term natural resource, to think about nature as simply a source for materials for us to extract. And also the recent creation of natural assets, a new asset class in the stock market, is an example of trying to enclose nature within the economy. Whereas the truth is that you cannot have a successful economy without a healthy ecology, without a healthy climate, without a healthy environment. And so we need to reverse how we look at it. So without having time to really talk in a lot of detail, I just want to end with a couple more slides. One is that the teachings of the climate also point us towards real climate solutions, towards enabling us to discern between false solutions and real solutions, what is true engagement with the climate problem. And finally, when it comes to education, because we need to think critically about all of these things, I want to point out something, which is that in the theory of transformative learning, there is a concept called an epistemic shift. So when you have deep learning, when a student has deep learning, experiences deep learning, then they cross a kind of cognitive and affective threshold where their conception of the world fundamentally changes. It's both an emotional and an intellectual shift. So the person cannot go back to being the same as they were before. This epistemic shift is even more important. Of course, it's important for our students, educating the future, but it's even more important for community leaders, for government officials, for policymakers, for those who are so used to the current system that perhaps it's harder for them to see beyond it. So let me end, because on the auspicious occasion of the 75th year of India's freedom, and particularly remembering my grandmother who took part in the salt satyagraha, I want to end with this, that the project of freedom is always incomplete. And we have to think about, we cannot call ourselves free just because the British left in 1947. The project of freedom is always ongoing. How can I call myself free if others in my country are not free? So what we want, what we need for true freedom is freedom from economic want, freedom from discrimination and exploitation on the basis of caste, class, and religion and species, freedom from toxic and unhealthy environments, freedom from climatic and ecological disasters, freedom from a destructive dominant paradigm. Let me end with Tagore. Into that heaven of freedom, my father, let my country awake. Thank you.